Hello, everyone. We are excited to talk here about data lake on AWS. More specifically, we are going to walk through the use cases, why you need data lake on the AWS, and how to process data lake tables using AWS Glue, Amazon Athena, and Amazon Redshift. I am Nori, a principal big data architect on the Glue team, AWS Glue team from Amazon Web Services. I'm responsible for designing the capabilities of AWS Glue and also responsible for building software artifacts that help customers build data lake on AWS Cloud. Akira, could you please introduce yourself?
Yeah, of course. I'm Akira, a senior software development engineer working for AWS Glue Spark team. I am a long-time Apache Hadoop contributor, committer, and PMC member. And last year, I joined AWS Glue, and since then, I'm working for Apache Spark. And so I led the integration with open table format, such as Apache Iceberg, Apache Hudi, and of course, data lake with AWS Glue. And so we are so excited. So we are usually working from Tokyo. We are Tokyo, Japan. And we are excited to talk here in Data AI Summit. Yeah, thank you. Hand over to Nori.
Thanks, Akira. So, okay, let us start from very beginning of the context here. Databricks was started on AWS. Many new innovations are developed first in AWS platform. Thousands of customers have implemented Databricks on AWS to address all their analytics use cases. Databricks is easy to subscribed from AWS Marketplace, and Databricks and AWS are constantly innovating each other to deliver service enhancement. As many of you already know, Data Lake is an open source project that helps implement modern data architecture commonly built on top of Amazon S3 or other cloud storages. With Data Lake, you can achieve AC transactions, time travel queries, change data captures, and other common use cases in the cloud. Today, in AWS, Data Lake can be used in a variety of AWS services such as Amazon EMR, AWS Glue, Amazon Redshift, and so on. AWS Glue is a serverless data integration service. With Glue, you can focus on your data itself because Glue is serverless. Glue Spark jobs start up within 10 seconds. You will see once you started Glue job with, let's say, 100 workers, you will see all the 100 workers will be spin up within 10 seconds. And you can start processing the data on Apache Spark immediately. It removes obstacles that require infrastructure setup. At the same time, if data volume goes up, you are not bound. Glue will allow you to scale as much as you need. Glue engines are open source. We support 3 different runtimes, Apache Spark, Ray.io, and simple Python runtime. You can bring your own preferred any open source library to the runtime, so you can continue enjoying the popular open source project ecosystem innovation, and there is no lock-in. Glue provides a wide range of the data integration capability. Glue has all-in-one package. Then, why AWS Glue is good for data lake? In another word, what are the typical use cases to use AWS Glue with Data Lake together? There are 3 major reasons. First, AWS Glue is designed to be optimized for AWS services. It provides powerful serverless data integration capability for all enterprises using the AWS ecosystem. Second, Glue enables you to implement data integration on visual interface. It does not require deep expertise in this area. The third, AWS Glue supports various different kinds of the connectors. It means you can connect to on-premise data sources, AWS data stores, other cloud data stores, and of course, SaaS applications as well. Okay, let us start from the first pillar, optimize for AWS services. Let me hand it over to Akira.
Thank you. Thank you, Nori. Thank you, Nori. Yeah, I'll talk about the first reason, optimized for AWS services. AWS Glue has several useful components for data processing. Let me explain Glue. First, let me explain Glue jobs and Glue crawler. Glue Spark jobs run on top of Apache Spark. It has a job script to achieve business logic and data integration. Of course, Glue Spark job supports data lake. In terms of data lake, Glue jobs can read data from Delta table, which is stored on Amazon S3. On Glue jobs, you can integrate Delta table data with other data sources. For example, you can join data on Delta table with DynamoDB table, RDS SQL Server, MongoDB Atlas table, and many other data sources. You can also perform ETL logic, such as converting data types, renaming fields, adding columns, and almost arbitrary operations as you want. Of course, you can read from other data sources and ingest data into Delta table using Glue jobs. On the right side, AWS Glue crawler is another component of AWS Glue. And Glue crawlers automatically scan data and populate table metadata into AWS Glue data catalog. The catalog is serverless, Hive Metastore compatible data catalog. With Glue crawler, you can easily register your Delta table into Glue data catalog and make them queryable from different engines such as Amazon Athena and Amazon Redshift, of course, AWS Glue jobs. Next, I'll introduce the details about how Glue job supports data lake. Currently, there are 3 options to bring data lake library into AWS Glue job platform. The first one is the left side, native integration. You can use data lake in AWS Glue jobs with specifying only one option to enable native integration. The version in native integration is fixed to keep compatibility. For example, Delta 2.1.0 is supported in Glue 4.0, and the Delta version won't be changed in the future. This is because you would be surprised if you suddenly upgrade the versions that you are using in daily ETL jobs. So, yeah, so we really care about the compatibility. If you want to use different versions other than native integration, you can use Marketplace connector or custom connector. Marketplace connector also provides the Delta library packages and more flexibility in versions. And finally, custom connectors are the most flexible option. To enable custom connector in Glue jobs, you can put your own libraries, of course, Delta libraries, into your S3 bucket, register the S3 library path, and then the libraries will be automatically added into your Spark runtime. In this time, we will focus on native integration because it's the easiest option for you to use Delta Lake on Glue jobs. With a native integration, you can use Delta Lake in just only one option. You can put job parameter key, hyphen Delta Lake formats, and set value to Delta, and that's it. Delta Lake provides both Java and Python libraries. So with specifying this option, the libraries are automatically set to Java class path and Python's path. For that reason, you don't need to set any additional configuration to use Delta Lake libraries. Okay, now you understand the overview of AWS Glue and its support for Delta Lake. Then I'd like to talk about the positioning of AWS Glue in AWS Analytics services for you to better understand how Delta Lake can be used inside AWS. Here, Glue is optimized for AWS services, and Glue sits at the core of AWS Analytics services. As implied by the name, it glues various AWS services and analytics services together by creating connections between them and allowing bidirectional data transfer among AWS services. Inside the AWS Glue, in this presentation, I already explained AWS Glue jobs and AWS Glue crawlers can natively support Delta Lake. And also, I want to talk about Glue data catalog. So, yeah, in addition to that, AWS Glue catalog can be utilized by AWS Glue jobs as well as other AWS database and analytics services. So in other words, so AWS, Amazon Athena and Amazon Redshift can query to Delta Lake using AWS Glue catalog. So yeah, I would like to talk about the Glue data catalog for more details. And I would like to talk about the contribution. So we want to improve the usability when using Delta Lake with Glue data catalog. So we are proposing a design document to open source community, so Delta Lake community, of course. The design is to allow Delta Lake to call Glue data catalog API directly instead of calling Hive Metastore API by separating catalog-specific implementation so that Delta Lake can output more detailed information into Glue data catalog using its own native APIs instead of Hive Metastore APIs. For more details, you can check the GitHub URL issue 1679. And we will provide more detailed design doc in near future. And so you can search, so maybe you can search with Glue data catalog and Delta Lake in GitHub. Yeah, now I talked all about AWS Glue, including Glue jobs, Glue crawler, and Glue data catalog, and its support for Delta Lake. In addition to that, not only AWS Glue, but also multiple AWS services can support Delta Lake. Amazon EMR supports Delta Lake natively, and Amazon Athena supports Delta Lake in both Trino and Spark engines. Amazon Redshift Spectrum supports Delta Lake, but it's manifest table only, Delta manifest table only, and I'll talk about Delta manifest table later in the next slide. AWS Lambda can support Python Delta Lake library through AWS SDK for Pandas. It's formerly AWS Data Wrangler, and the package name is AWS Wrangler. So you may know that name, and that's the AWS SDK for Pandas. And you can use, you can install by pip install AWS Wrangler, and then you can read and write data lake tables. Yeah, then the end of this section, I'll show you the demo to query Delta table from Athena and Redshift. But before moving to demo video, I'll need to explain Delta native table and manifest tables. Native Delta table is natively created Delta tables that extends Parquet data files with a file-based transaction logs and metadata. The other one is a manifest table, which is represented as Symlink table based on Parquet files that can be used by non-Spark processing engines such as Amazon Redshift. In the next demo, I want to query Delta table from not only Amazon Athena, but also Amazon Redshift. To make Delta table queryable, it's important to create a manifest table which is based on the Symlink text format. The standard way to create a manifest table is to run generate command in Spark SQL. But on AWS Glue platform, there is another way to use AWS Glue crawler. Another way to use Glue crawler, it simplifies generating a manifest table. And in this demo, I will choose this way. Then go to the demo video. But before showing the demo video, I'll quickly tell you about the outline of the demonstration. First, launch Databricks notebook and write Delta table file into S3. And second, launch Glue crawler to crawl. It actually crawls Delta files and populate table definition and the into Glue data catalog. And it creates both Delta native tables and manifest table. And finally, use Amazon Athena and Redshift to query the Delta Lake table. Let me play the video. This is a Databricks notebook. And you can run individual scripts by running cell one by one to run the scripts written in the notebook. This cell is a notebook, so Databricks sample demo. It's copied from sample demo, and it's sample data read sample data, and it converts to data frame. So you can see the data using display function. And finally, write delta table. So df.write.format delta to write data to S3. Then the delta table is written to Amazon S3. And so you can see in the video, and the objects, actual data files are stored in S3. So click one of the partition, and there are 4 packet files. That is the record. And you can also see delta log files. So it contains metadata and delta transaction logs. So yeah, you understand delta table is located in Amazon S3, but its table definition is still in Databricks, and it's not in AWS. So we will need to create a Glue crawler to populate table and queryable from Amazon Athena and Redshift. So let's create a Glue crawler. So adding a data source and choose delta table, delta lake as data source, and then copying the S3 location, table location, copy the S3 URL and paste it to table path. Then it's almost done. Next, we will need to set up IAM role that can access to the required resources such as Amazon S3 and Glue data catalog. Then go to the target database where the table information is stored. Go to next. Review the configuration we set, and the crawler is created, and run the crawler. So after 30 seconds, the crawler is finished, 32 seconds. So the video is accelerated for you to, And finally, the table information can be seen in Glue data catalog. Choose DICE database, and you can see the native event table. It has S3 locations and also table schema as well. Next, create another crawler. This is a Delta native table, and we will need to create another crawler to populate the stored as manifest table. So choose Delta Lake as data source, and copy the same table location, S3 table location. And it's important to choose create Symlink tables here and click enable write manifest. So then AWS Glue crawler automatically creates manifest table so that Amazon Redshift can query Delta table using the information. Setting output configuration, and next review the configuration, and proceed and running the crawler. After about 30 seconds, the crawler is finished, and you will see the manifest table in Glue data catalog. So refresh the table list, And yes, Symlink table is here. So it's important that the location is, yeah, the character is a little bit small, but it's Symlink format. It's written as Symlink format, and the table classification is packet. Then go to Athena to query the native table. Choose native event table. And yeah, preview table, click preview table to generate the select query, select SQL, and then you can quickly review the data into data on the review the data of Delta Lake on Amazon S3. Then go to Amazon Redshift to query Delta manifest table. Go to Redshift serverless and query Redshift query editor for you to easily write and execute any SQL. Yeah. Check this and go to the manifest table. It's really important to choose manifest tables. Yeah, here Symlink event, and generate select query and run it, and then you can see the same data. Yeah, that's it. Yeah, thank you. Now you understand how data lake is integrated with multiple AWS services, not only Guru, but also Athena and Redshift. Then we will go to the next section. Let me hand over to Nori.
Okay, thank you, Akira. The previous section covers the first reason to use AWS Glue with Data Lake. AWS Glue is useful to make data lake tables accessible from different AWS analytics services. Now let's look at the second reason, Visual ETL experience. AWS Glue has Visual ETL capability. You can define your own ETL logic visually for Delta Lake tables. I guess some of you are pretty familiar with coding. Some may prefer visual user interface rather than coding. In this area of data engineering, it is very common to have people with different skill set. AWS Glue offers a variety of user interface for every skill set. A visual drag and drop interface for no-code users, a built-in notebook interface for interactive job authoring, and finally, Job API interface for developers who want to submit their own Python or Scala script. Regardless of the interface you use to author your job, you can get the benefit of massively scalable Glue engine. Although there are these three different user interfaces, this session will focus on the first one, Visual ETL. The Glue Studio Visual Editor is a flow diagram interface to design large-scale data movement and transformation processes. It produces Apache Spark code automatically so users can process their own big data without the learning curve. It is ideal for IT professionals who have the experience in other ETL or software like Informatica and Talent and need to move the data and apply common transformations on it. In this demo, we will focus on visual data integration using Glue Studio Visual Editor. Here's what we will demonstrate in this demo. First, we will define two data sources from Amazon S3 bucket. Both are JSON dataset. Then we will add join transformation between these two data sources, then ingest data into Amazon S3 bucket using Delta Lake. Let me start the video. This is a Glue management console. You can choose Visual ETL, and this time we will create a brand new visual job. So let's choose a blank script. Now, the first you need to provide a Glue job name here. This time we name it person membership visual. In the blue button, you can choose any data sources. Here we choose S3 source for the JSON dataset. We name it persons and provide the dataset location from Amazon S3 bucket location. This time we are using the public dataset, public bucket, and provide the S3 path. Now this dataset is ready. However, we want to make a small transformation of it because we don't need all the columns that is included in this JSON file. So we choose drop field transformation and add it to this visual flow. If you choose the drop field, then you can selectively choose some of the columns you want to drop. This time we don't need very complex information, so we just choose 3 different columns for array columns. Now the first dataset is ready for join. Then let's define the next data source from Amazon S3. We need to provide another S3 location for this one, this dataset. So we provided it. Then that's it. Now 2 data sources are ready for transformation. We just choose another data transformation such as join transformation. Join transformation joins 2 different sources. Now we want to relate this join transformation with these 2 added S3 data sources. Then we relate it here. Then now you can see one is coming from drop field, one is coming from membership. Then what you need to provide is just to define the join condition here. This time we choose ID column from drop field or data source. Then we choose person underscore ID column coming from membership data source. Now join transformation is ready. Then finally, we define the target destination as a S3. So we define the S3 node here. As you can see from the pull-down list, there is Delta Lake format already supported in this platform. So you just need to choose Delta Lake. Then provide the S3 location for destination. This time we choose our own bucket for the destination. Then this visual diag is completely defined. What you need to provide additionally is to provide the IAM role, which has sufficient permission to access the data sources and destination. Then it is ready. You can just save it, then run it by clicking the orange Run button. If you click this one, then Group platform will spin up the ephemeral Spark cluster within around 10 seconds, and you can track the progress in this Runs tab. If you refresh, you can just track and progress, and you will notice that the job finishes in 1 minute and 36 seconds. Now, as you can see in the S3 console, the new data source, data destination is successfully written to the Amazon S3. And it means your Delta Lake table is now located on S3. And of course, the data files are located on S3 as well. It means you can query it from Databricks. So let's go to Databricks workspace and see the notebook and run this cell. Since the S3 bucket is already mounted here, so you can just query it as a Delta Lake table. So now we cover 2 different reasons why Groove is used with Delta Lake. The third reason is various supported connectors. AWS Groove provides more than 80 connectors. They are all bidirectional connectors. It means you can read it from or write it to any of those data sources supported in the connectors. Built-in connectors are out-of-box connectors that are managed by us, AWS Groove. So it supports various data sources such as JDBC, Amazon S3, RDS, DynamoDB, Aurora, and so on. Marketplace connectors are the third-party options. you can discover the variety of the connectors there. And third option is custom connectors. If you have a very domain-specific use cases, you can just bring your own implementation, your own library as a connector, then use it in the visual interface. As many of you may expect, many AWS data sources are natively supported in AWS Glue. However, AWS Glue also supports non-AWS data sources. For example, Glue supports common open source databases such as MySQL, MariaDB, Postgres, and also common proprietary databases such as Oracle DB, Microsoft SQL Server. Even when they are located in your on-premise, Glue can access to your on-premise databases through the network when you configure your network between your own on-premise environment and AWS. For NoSQL engines, we support MongoDB, MongoDB Atlas, Apache Cassandra. For streaming, we have Kafka. We also support cloud database houses such as Snowflake, Google BigQuery. We also support cloud data storage such as Google Cloud Storage, Azure Data Lake Gen 2, and Azure Blob Storage. We also support search engines like Elasticsearch and OpenSearch. And moreover, AWS offers AWS App Flow to integrate with various different SaaS applications. So together with AWS Glue, AWS App Flow make all of these data easy to access through Glue Data Catalog. So as you can see in this screenshot, you can easily select the connectors in the pull-down, then use it in the visual flow. The next demo will show how the connector looks like. So in this demo, we will ingest data from Microsoft SQL Server and write it to S3 using Delta Lake. Let me start the demo. The same console, we create a new visual ETL job from scratch. So we just choose this one, blank canvas. Then create. First, we name this job, or this time we name it MS SQL Server 2 Delta. Then choose the blue circle to define the data sources. This time we choose the Microsoft SQL Server as a source. Since we pre-configure the connection information, including credential or host name or whatever, we just choose it here. Then we provide the table name here. Then this data source is ready. This time we don't need any transformation. We just want to replicate the same data from SQL Server to Delta Lake. So we just provide the S3 data target here. Then the same way, we choose Delta Lake format as a format. Then finally, we provide the S3 location here. This time we choose our own S3 bucket here. Then the visual DAG is ready. You can save the, and after that, we again need to provide the IAM role, which have the sufficient permission for the data sources. Then save it. Then run this job by clicking this orange run button. Then a Glue job is started here. When you click the run button, you will be able to track the progress of the job. After 1 minute and 44 seconds, it finished. It means that all the data is successfully written from SQL Server to Delta Lake. So Delta Lake is, again, located on S3. So you can see the data files on S3, like this. It means since the data table is located in S3 bucket, you can query it from Databricks again. If you go run this cell, then you will see the records that is originally coming from Microsoft SQL Server. Okay, the record is returned. In the demo scenario, we demonstrated very simple operation, like simple reads and simple writes. But if you want to do advanced operations such as time travel, upstart and delete, rolling back, and so on, then you can, of course, use other job interface like notebook or job platform or whatever. If you want to understand more, we provide some samples, or 3 samples for Delta Lake specifically. So you can take a look at the GitHub repository to understand more. Summary, in this session, we covered how to process Delta Lake table on AWS Glue, and also how to query Delta tables using Athena and Redshift Spectrum. You learned 3 reasons why Glue is good with Delta Lake. First one is that Glue is designed for or to be optimized for AWS services. Second is that AWS Glue enables you to implement the data integration on visual interface. The third one is that Glue supports various connectors, including on-premise, AWS data stores, and cloud data stores, and so on. As we demonstrated, once you place your Delta Lake table on Amazon S3, your bucket, then you can transparently query it from both Databricks and also AWS Analytics services. So let's start using Delta Lake with AWS Glue together from today. So this is the summary of the session. But if you have any questions, we want to cover this. Thank you. Mike is coming. I can hear, but please use the microphone.
So great functionality. To me, it sounded like I don't need Databricks if I'm using Glue, right? Am I right? I mean, all the analysis and all the ETL I can just do on Glue. Mm-hmm. I only need Databricks. Is my understanding right?
So it totally depends on what you want to achieve. So if you want to do every ETL on Databricks, it's totally up to you. If you want to do visual ETL, if you want to combine all the different data sources, then AWS Glue may be the right option for you. So it totally depends on the use case. And we want to explain that you can choose the best option for individual use cases.
Hi, I've seen AWS Glue Studio. Is there a version control on it?
Thank you for asking that. Actually, we have the version control on it. It can integrate with the standard Git providers such as GitHub, and you can save the job and DAG information in the, by committing the changes. And you can also deploy the changes from the GitHub repository or other Git-supported things such as Git code commit.
Thanks.
Thank you.
The Postgres SQL connector, is that a one-time batch move over to Delta Lake, or does it incorporate any change data CDC type functionality so that it's not continuously overwriting?
Okay, thank you for the question. So the question is it possible for incrementally ingest the data from SQL Server to Delta Lake, I guess. And it is possible. So Glue has the capability called job bookmark. Job bookmark allows you to incrementally read data from JDBC or Spark S3 or something like that. So it means you can, when you run Glue job twice or 3 times, then you can just only read delta between these different job runs. But if you want to have more control on that, of course, it is also possible. And if you want to achieve the true CDC, then you may need to integrate with AWS DMS to replicate the data from SQL Server or other databases using binary log, transaction log. Then once the data is coming to S3 or Kinesis, then you can process Glue to reflect data to the destination like Delta Lake using upsert and merge. So there are two different options. And the job bookmark is simple one, and the DMS with integration is the advanced one.
So in your first demo, the manifest table, how do you keep updated automatically if the underlying delta table is updated? Yeah.
So your question is how do we keep the delta lake table up to date?
The manifest table.
Manifest table.
Yeah.
So that's a really good question. So if we want to update keep the manifest table updated, every time when you make the query changes on the native delta table, source table, you just need to rerun the crawler to reflect the manifest changes. But note that even if you use the outdated manifest table, it just reads old data with the old transaction. It doesn't. It means it's not broken. It just reads the outdated data. If you rerun the crawler, then you can see the latest records. So it is recommended to schedule the crawler at some frequency, such as 1 hour or something like that.
Yeah, and yeah, so for that reason, AWS Glue Crawler has its own scheduling feature. So you don't need to write script, and so yeah, it's out of box. Yeah, thank you.